Assistant Professor in Chemical Engineering Department at LJIET Institute of Engineering and Technology. The subject that I am going to take is petroleum refining and petrochemicals. So moving with the lecture. So now starting with chapter 2. Your chapter 2 is about properties of crude and petroleum products. Okay. So what would be the outline of your chapter? Okay. We will study about the type of the gases. Okay. Type of gases which is available and their compositions. Okay. See, gaseous fuels are also one kind of fuel. Like solid fuels are there, liquid fuels. Similarly are the gaseous fuels. Now petroleum industry is very peculiar here. Okay. You have many type of gaseous fuels. Some are derived from the petroleum itself and some are processed. So we will study about their and their composition. Then types of gasoline, its important properties and tests. Then types of naphthas, the important properties and application. We will learn what is naphtha, also the term itself. Then important tests and properties of kerosene. Similarly that of diesel. Okay. And heavy fractions also like lube oil, bitumen, asphalt and the important properties. Okay. Now, this is the description of a normal atmospheric distillation tower. Okay. In GIST, how we start. In GIST, this is defining your refining process. Okay. How your crude oil is subjected to refining. Okay. So, starting with what you get your light intermediates. Okay. From C1 to C4, gases you get. Similarly, you get straight run gasoline, naphtha, kerosene, light gas oil, heavy gas oil, residue. Okay. Now, these all are the fractions. Okay, they are not a particular or single component. They are the fractions at different cut. Like for straight run gasoline, see the range of carbon is from C5 to C8. So that is a category of straight run gasoline. Okay. Now, it is used for more processing to get gasoline. Okay, the gasoline which is sold into the market. It is you can say it is a brand name. Okay, brand name because a blend is there. After blending it, after making it suitable for the transportation as a purpose to, to do its purpose as a transportation fuel, then it is sold to the market. But its raw fraction is what? Straight run gasoline. Okay. After more processing, okay, like after increasing the octane number, then it is sold to the market, and that is known as gasoline. So these are the fractions which we get in initial point when our crude is subjected to distillation. So the purpose of this chapter is to know the properties of those fractions. Okay, what are their composition, what are the properties, and what are some important tests which you need to know to judge its quality, to further implications. Okay, like for straight run gasoline. Okay, the straight run gasoline, that fraction which you get, it has low octane number. So see, that is its property, its quality. Now in market gasoline, what is petrol? Okay. The petrol which I need for my transportation fuel, it should have high octane number. So see, it is now again processed. So that's why I need to conduct some test on that. Okay. So as to know what is the existing quality of it. Okay. What is the existing property of that fraction. So that would be covered in this chapter. Now starting with first category. Okay. We are starting with the gaseous fuel. Your gaseous fuels are divided as, now the first category here is petroleum gases. The gases, okay, the gases which you get from petroleum itself, from petroleum industry itself, that is called as petroleum gases, okay. Actually, in exam also, if they want to ask about the gaseous fuels, okay, category wise, how they would ask, the question would be like, explain about the naturally available petroleum gases. So you have to mention, you have to describe about these gases. What are the gases involved here? Natural gas, associated gas, dissolved gas, casing head gas, refinery off gas, LPG, etc. Okay. Now the second category here is processed gas. From name itself you can see processed gas. Okay. These gases are available from the processing industries. Okay, when certain reactions are done. Okay, for example, cracking industry, cracking. Okay, in cracking, your heavy fractions are cracked into light fractions. Okay, with that you get some certain gases also. So those gases are categorized in processed gas. What are those gases? Water gas, reducer gas, coke oven gas. Now starting forward, first is natural gas. Okay, it is in my category of petroleum gas. So what is natural gas? See, natural gas is the gas which is readily available as finished product, okay? It contains mainly methane. So what's the composition of methane here? It ranges from 85% to 98%. See, just like crude oil has its deposit, natural gas also has its deposits, okay? So the gases which is obtained directly from its deposits, that is called as natural gas. From name itself you can see naturally available as finished product, okay? Now, what are the other proportions which are present? Okay, it is not pure. Of course, it is not pure methane. So, some proportions of other gases like ethane and propane is also present. So, this is about your natural gas. Okay. Now, it has highest calorific value. Okay. Now, before starting this, knowing about calorific value, we must know the definition of calorific value. So, what is calorific value? The amount of heat liberated when 1 kg of fuel gets completely combusted. Okay, we are talking about complete combustion. Now, why natural gas have highest calorific value? See, the composition is mainly methane. Okay, CH4, that is the chemical formula of methane. Okay, when it is subjected to burning, okay, methane will react with oxygen. I am talking about complete combustion. Means if I'm burning it in presence of excess oxygen. Okay, I'm not limiting the combustion. Okay, not partial combustion, full combustion. Then, because it has highest constituent of methane, it can be readily oxidized to carbon dioxide. Okay, because about 85 to 98% methane is there. Okay, the fuel which can be combusted is in highest quantity, so it can be readily combusted. It can be readily oxidized to give carbon dioxide. So see, hence it will evolve much amount of heat. Hence it has very high value of calorific value. Now next is associated gas. So what is associated gas? It exists as separate gas cap over liquid phase. You can see from the figure, okay, the gas is forming a capping over oil, okay. So it exists as a separate gas layer over the liquid phase. Now, what is the composition? It mainly contains methane, ethane and propane. Now, of course, it may contain little bit of butane and pentane. See, gases are up to in gas phase up to C4, that is up to butane it is gas. Now from C5 the exhibition of liquid phase starts. Okay, but it is possible that these gases may be this butane and pentane may be present as some liquid droplets in this gas. Okay, it might be dispersed, but they are condensed, and that is butane and pentane which are condensed. Okay, it is called as natural gas liquid. The third category of your gas is dissolved gas. Okay, from name you can say it is dissolved. Okay, it is present in liquid hydrocarbon in dissolved state because of high formation pressure. See, beneath the earth crust, the temperature and pressure is very high. Now, because of high pressure, it is possible that these light liquid hydrocarbons are dissolved in the crude. Now, when they are excavated out, okay, when they are taken out from the earth crust, okay, of course, from high pressure, I am bringing to atmospheric condition. So, this, what would happen? The gas would be stripped out of the oil. Okay. Now, the remaining dissolved gas, how I get it? When I'm subjecting my crude oil to heating, okay, these gases again come out. See, directly your crude is not fed into the distillation column. Okay, we saw earlier in the figure also that first of all, your crude is subjected to heater. It is preheated. Okay, in a furnace it is preheated to a certain level of temperature, and that preheated crude is then sent to distillation column. So in that preheating only, certain amount of this dissolved gas are taken out. Fourth category is casing head gas. Now this casing head gas is same as natural gas, but the proportion, the proportion of methane is less, but high amount of ethane and propane is there. Now it is simply produced during oil production. Okay, when you're taking out the oil, this kind of category oil, this kind of gas is also present, but it is in very less quantity. Now, next is refinery of gas. Okay, of gas. Okay, you are getting as a second product. Okay, as a byproduct which you are getting, that is called as refinery of gas. Now, this gas is mixture of saturates and unsaturates. Okay, saturates are your straight chain paraffins. Okay, which only have one single bond. Unsaturated can be double bond, triple bond. Okay. Now, this type of gases are generally used as feedstocks for petrochemical industries. See, when I'm talking about unsaturated, just keep in mind that unsaturated's major application is in petrochemical industries. Now, when these gases are formed, okay, it is formed in cracking and reforming operations during thermal degradations. Okay, see, besides ADU, there are many other units like cracker is there, coker unit is there. You will learn further. Okay. So where thermal degradation is taking place, okay? What happens in thermal degradation and cracking kind of operations? Your heavy molecules, okay? Your big molecules are cracked into small molecules. And when cracking happens, certain amount of gases also are formed. Those gases are called as refinery of gas. Now it may be saturated and unsaturated. Example, ethene, okay? Ethene is a form of unsaturated. Of course, ethene is used in to make polythene. So what is that? It is a petrochemical industry. Now, another type of gas is liquefied petroleum gas, LPG. The major use, when you talk about LPG, we talk about the cylinder in home which we use for cooking purpose. See, LPG is a subsidized gas, okay? The government has specially aided it, okay? It is subsidized. It has been stated by the government that gas has to be used for cooking purpose, solely for cooking purpose only. Now, talking about the composition, okay? It mainly contains propane and butane, which is liquefied at high pressure, okay? What we do is, this gas is liquefied at high pressure and it is stored in metal cylinders, okay? That way you get your LPG. Now, there are different grades of LPG, okay? We have different grades of LPG based on the composition of the propane and butane gas. So, what are the grades? Okay, first grade can be that in your mixture of butane and propane, butane can be more. Then you have equal butane, equal propane, and butane and more propane. Now, why is the need to divide into grade? Okay, see, here comes the topic about pressure condition. Okay, in India, okay, we have low altitude area also, high altitude area also. Okay, talking about north, okay, high altitude area. As we go up to that, in height, pressure decreases. Okay, talking about northern areas, pressure is less. Okay, so and one more thing you have to note is that butane is heavy. Butane is heavy than propane. Okay, so the tendency of heavy gas is to settle in the ground area, okay, below the area, okay. It has tendency to settle near the ground. So why? So in northern area, what we do, because pressure is less, we keep the composition of propane more, okay, because propane is light than butane. Similarly, that is the reason why we are dividing your LPG into different grades, okay. Now, about the property of this gas, it is odorless, hence mercaptans is added. Okay, mercaptans are a compound of sulfur. Okay, it is having sulfur in it. It has a very pungent smell. Okay, so to detect the leakage, mercaptans are added. A very important note here. See about its expansion coefficient of this gas. See how this gas can expand. 1 liter of a liquid LPG can expand up to 270 liters. Okay, so you see if there is a leakage of 1 liter LPG, okay, from cylinder 1 liter liquid LPG is pasting out, it means it will cover up to area of 270 liter. Okay, in vapor phase, the area that would be covered would be 270 liter. Hence, this makes it very dangerous. Okay, very dangerous gas, because if you don't know about leakage, if mercaptans would have been not there, you wouldn't be able to detect the leakage. And see, if ignition source is there, it can cause a very heavy damage. See, the molecular weight of air here is, we must know about it. It is 29. Okay, the molecular weight of air is 29. Now, as this gas LPG is mixture of propane and butane, its molecular weight is more than air. It is dense than air. Now, as it is dense than air, if it is leaking out, okay, LPG will settle on the ground, okay, it will settle on the ground. It will not evaporate, okay, it will not vaporize and go into the sky area, okay, towards the ceiling. It will not go there. It will settle in the ground. Hence, this makes it a little dangerous, okay. Now that was about your petroleum gases. Now talking about processed gas. The first type of gas is water gas, okay. See, these gases like water gas, your producer gas, coke oven gas, these gases are formed when certain reactions happen, okay. Water gas is also called as blue gas. Now why blue gas? Because it burns with blue flame. Blue flame, it is this, what is the significance of blue flame? Why blue flame? See, it shows that your complete combustion has taken place, okay. When even in home also, when we burn LPG, okay, it burns with blue flame. And if yellow flame occurs, what we do is we clean the burner, okay, because some residue might have been sticking to it. So what does it show? That it is burning with, it is happening, it is undergoing complete combustion, okay. Means monoxide is not formed, complete dioxide is formed. So water gas is also known as blue gas because it burns with blue flame. Now how it is made? It is made by passing steam over red hot coal maintained at 900 degrees Celsius to 1100 degrees Celsius. So the reaction is when C reacts with carbon reacts with H2O, it gives carbon monoxide, and when it's again it gives carbon dioxide, okay. So partial oxidation and complete oxidation is taking place, okay. So now you can see monoxide is formed in major quantity, about 43%, okay, and of course H2 is formed. So I can say it is this water gas, it is my source of H2 gas, and it is also used as fuel gas. The CO2% is 3%. What does it show? That in this reaction mainly partial oxidation takes place, okay. Now fuel gas, it means we can use this fuel, we can use this fuel. Now fuel gas, it means we can use this gas as a fuel, okay. Now if I'm burning this gas, so what will happen? The carbon monoxide, it has the tendency to oxidize again. So what will happen? My carbon dioxide will react with oxygen and will get converted into carbon dioxide, okay. Hence it burns with blue flame because there is still possibility to get oxidized because carbon monoxide is present in large amount. Next gas is producer gas. Now this gas is made by passing air and steam mixture over red hot coal maintained at 1100 degrees Celsius. Water gas, you are only passing your steam. Now here air is also there. So what happens here is, now also called a synthesis gas because it is synthesized. Now as air is also passed, so you can see the concentration of N2 has been increased. N2 is an inert gas, okay, it doesn't react. Carbon monoxide composition is now 27% only. So see, this makes that it has now less calorific value, okay. Calorific value, as we discussed earlier, if more amount of fuel is present, okay, if more amount of fuel which has the tendency to get oxidized is present, then only it will liberate heat. Now here composition of carbon monoxide is less, so it has a tendency of less oxidation to get converted into carbon dioxide. So the calorific value is less. The third type of gas here is coke oven gas. It is made when bituminous coal is heated at temperature of 900 to 11 degrees Celsius in a chamber. Okay, so these were the types of your gases which are taken into account as gaseous fuel. Okay, so that was for today's lecture. Thank you.